Example 7. Find the sum of the series. The sum from n equals 0 to infinity of x to the power n, where the absolute value of x is less than 1. Solution. Notice that this series starts with n equals 0, and so the first term is x to the power 0 equals 1. With series, we adopt the convention that x to the power 0 equals 1 even when x equals 0. Sidebar Tech Module 11.2 explores a series that depends on angle theta in a triangle and enables you to see how rapidly the series converges when theta varies. Back to the text. Thus, the sum from n equals 0 to infinity of x to the power n equals 1 plus x squared plus x cubed plus x to the 4th power, and so forth. This is a geometric series with a equals 1 and r equals x. Since the absolute value of r equals the absolute value of x less than 1, it converges. And 4, I believe definition 4 gives this definition 5, which is the sum from n equals 0 to infinity of x to the power n equals 1 over 1 minus x. Example 8. Show that the series, the sum from n equals 1 to infinity of 1 over n open n plus 1 close is convergent, and find its sum. Solution. This is not a geometric series, so we go back to the definition of a convergent series and compute the partial sums. S sub n equals the sum from I equals 1 to n of 1 over I open I plus 1 close equals 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 2 times 4 plus ellipsis plus 1 over n open n plus 1 close. We can simplify this expression if we use the partial fraction decomposition. 1 over I open I plus 1 close equals 1 over I minus 1 over I plus 1. See section 7.4. Thus we have S sub n equals the sum from I equals 1 to n of 1 over I open I plus 1 close equals the sum from I equals 1 to n of open 1 over I minus 1 over I plus 1 close equals open 1 minus 1 half close plus open 1 half minus 1 third close plus open 1 third minus 1 quarter close plus ellipsis plus open 1 over n minus 1 over n plus 1 close equals 1 minus 1 over n plus 1. And so the limit as n approaches infinity of S sub n equals the limit as n approaches infinity of open 1 minus 1 over n plus 1 close equals 1 minus 0 equals 1. Therefore, the given series is convergent, and the sum from n equals 1 to infinity of 1 over n open n plus 1 close equals 1. Sidebar, notice that the terms cancel in pairs. This is an example of a telescoping sum. Because of all the cancellations, the sum collapses like a collapsing telescope into just two terms. Figure 3 illustrates example 8 by showing the graphs of the sequence in terms a sub n equals 1 over open bracket n open n plus 1 close bracket, and the sequence open bracket s sub n close bracket of partial sums. Notice that a sub n approaches 0 and s sub n approaches 1. See exercises 78 and 79 for two geometric interpretations of example 8.